which makes your hard palate more firm than it would otherwise be. So if it's got a tensor inch name, it's V3. Okay. These are hierarchical. Any muscle that has the word palate in it is innervated by vagus, unless it's something called tensor palate, because tensor rule wins. So tensor palate is innervated by V3. Everything else with palate in it is innervated by vagus. Okay? Anything with the word glosso in it is innervated by the hypoglossal. That's fairly easy to remember, gloss. Except, okay, palatoglossal. Okay? Because palates are innervated by the cranial nerve 10. All other glosso things are hypoglossal. So anything with tensor in it is innervated by the mandibular division of trigeminal. Anything with palate in it is innervated by the vagus, unless it also has the word tensor in it. And anything with gloss in it is innervated by the hypoglossal, unless it has the word palate in it. So that's one way to remember all this. Otherwise you just memorize what the muscles are going to be. Okay, so here is the tongue. Okay, if you want to check if there's a problem with the hypoglossal nerve, you can ask the person to stick their tongue out. If they can't stick their tongue out, they probably got problems with both sides of their hypoglossal. However, if they stick their tongue out and it isn't straight, okay, that's what it should look like. But if they stick it out this way, it means that, and it bends to one side, it means the hypoglossal nerve is not enabling you to protrude your tongue on the right side. So there's something wrong with the hypoglossal on this side. Likewise, if it bends to the other side, there's something wrong with the hypoglossal on that side. If both hypoglossals are working, they should push the tongue out symmetrically. Okay, finally, sympathetics. And you'll be no doubt pleased to know that the sympathetics of the head are vastly simpler than the sympathetics of the rest of the body. Okay. This is just a review in general. Sympathetics are concerned with energy expenditure. Parasympathetics are energy intake. Right? So parasympathetics tell you to slow down and digest all your food. Sympathetics, energy expenditure, tell you to run away from the tiger that's about to eat you. Okay. There are obviously differences in the sympathetic distribution of the sympathetic system and the parasympathetic system. Sympathetics are in the body wall and the body cavity. Parasympathetics are mainly in the body cavity, but they do innervate mucous, lacrimal, and salivary glands in the head and the neck, but they don't do much in the body wall. Parasympathetics don't go to the body wall. The sympathetic system, okay, has dissectable ganglia, right? We saw a lot of those, all those paravertebral ganglia going up and down the spinal cord. In general, the parasympathetics in everything below the neck, the cell bodies are found in the walls of the organ being supplied, and you can't find them. So parasympathetics send preganglionics all the way into the body wall of the guts, and postganglionics you can't find. In the head, that is not the case. There are some dissectable parasympathetic ganglia in the head, and you've seen some of them, right? There was that little otic ganglion in there, and then there's a variety of ganglia that you'll see when you go under the tongue. So we couldn't find parasympathetic ganglia in the abdomen and in the thorax, but you will find them in the head. The sympathetic system, as we said, originates it's preganglionic cell bodies in T1 through L2 parts of the spinal cord. Okay, that remains true. Needless to say, there's not a spinal cord in the head, and we'll get to that. However, the parasympathetics, okay, have we know of two sources. We know that from what we've seen so far, we saw preganglionics coming from the vagus in the body and from S234 in the spinal cord. But you also know by now that in the head, there are a variety of these cranial nerves that are carrying preganglionics. So obviously the head, as you've probably figured out by now, has we've seen lots of parasympathetics and all these cranial nerves and such. We haven't talked much about sympathetics originating in the brain or anywhere else. And that's because they don't. The only source of parasympathetics wherever you are is in T1 through L2. So how do they get to the head? Okay, well, interesting. So all sympathetics originate mainly from T1. They all originate from T1 to L2, and that stuff in the head is coming mostly from T1 and T2. So the upper part of the preganglionic sympathetics are coming from the upper part of the thoracic levels of the spinal cord. However, all the sympathetics in the head are postganglionic because the preganglionic synapse in the superior cervical ganglion, which is in the neck, and the only thing going up into the head are postganglionics. Moreover, the postganglionics in the head are primarily distributed along the internal and external carotid arteries. Some can go to these latter cranial nerves and ride with them in some of these plexuses, but mostly the postganglionic sympathetic innervation of the head is traveling through the arterial system. Okay, you won't find any of those ganglia that we found along the spinal cord, going into these gray and white rami communicons. You won't find any of that up in the head. You'll find a great big superior cervical ganglion, and everything coming out of that is going to be postganglionics, and then mainly going to be riding with the arteries. Okay, so here is your sympathetic trunk. Okay, coming up in the neck. You'll see where it lies in a few minutes. And okay, these preganglionics are coming up, going into this big old ganglion at the top of the neck. They're going to synapse there, and then these postganglionics are going to go out and go into this carotid plexus and follow branches of the carotid arteries into the head. The sympathetics in the head, they're responsible for constricting the little arterioles around the eye. So if you've got bloodshot eyes, it means the sympathetics going to the area around your eyes aren't working as they should. And they also contract this muscle called the dilator pupillae, which dilates your pupils. That's fairly straightforward. They also contract this little muscle here, this superior tarsal muscle, which keeps the tarsus up here, this thing in the upper eyelid, it keeps that sort of firmed up. So if this sympathetic's not working, the upper eyelid will droop a bit. It won't be as firm as it should be, and will cover more of your eye than it normally would. Okay, and as in other parts of the body, the sympathetics contract the arteriopilae muscles, little muscles that sort of stand up. They stimulate secretions of sweat glands, and they stimulate secretions of salivary from some salivary glands, so they can affect the effectiveness of the salivary glands. Okay, So here's a cross section. What we're going to do today actually is we're going to sever this area around here. So we'll get to see the back of the pharynx right in there, and then it'll leave the stump of the neck here. So the sympathetic trunk is lying right back in here, okay, in this retropharyngeal space, right at the edge, one on each side, obviously, at the edge of the carotid sheath. So here's a schematic, right? So here in the neck, as we said, you don't really find clear ganglia at each spinal level like you do down in the thorax and abdomen. Rather, there's a big ganglion down here at T1, C8 and T1, known as the inferior cervical ganglion or stellate ganglion, because it looks like a star. A little bitty one above it, the middle cervical ganglion, and then way up here at the top, okay, from C1, C2, C3, and C4, all the preganglionics that have come up here, okay, and all the preganglionics that have come up here, sending postganglionics out to these cranial levels, and also postganglionics that go up into the head, riding on these blood vessels. Okay, so here many of you probably saw this. Okay, so here we are in the root of the neck, right? There's your common carotid, subclavian, okay? Lying on these muscles, lying on the back of the neck, right in front of the cervical vertebrae. There's that inferior cervical ganglion, and then way up here, much higher, you probably saw the inferior ganglion. You might have seen the middle ganglion. You go up further. Go back. Nice to go back. Oh. Back. Okay. Way up high, you should find the superior cervical ganglion. Okay, you'll see it in today's section. Okay, it lies on the anterior surface of the muscles called longus colli and longus capitis, which are going to be these guys lying back here on the ventral side of the vertebral bodies. Okay, so that's where all the sympathetics come from in the head. What a common or a well-known problem is when something happens to the sympathetics going to the head, there's something called Horner syndrome. Okay, and what happens, or what Horner syndrome consists of, is, for example, the person has a constricted pupil. Okay, so the eyes are very, very tiny, tiny little pupils there, because usually when you go into darkness, the pupil will expand. You go into darkness and the pupil does not expand. It stays constricted because it's missing the sympathetics, which would cause it to dilate. The upper eyelids are sort of droopy. They're not wide. You can't open your eyes really wide. Okay. The person doesn't have vasodilation going into the face, so they can't blush. And as I said, they can't constrict the little vessels in the eye, so they have bloodshot-looking eyes. Okay, and also their sweat glands can't work because the sweat glands in the face are driven by sympathetics, obviously. So Horner syndrome means there's something wrong with the sympathetics. It may be something to do with one of your carotid arteries or something, or somehow it's been hurt. Okay. Today, the next couple of dissections are perhaps gruesome. Today, we're going to pull the head off of the neck. As I pointed out in the slides, there's an area behind this visceral part, behind the esophagus, behind the pharynx, obviously behind the trachea. We're going to separate, and that's connected to the head, all these soft structures. We're going to separate that from the posterior part of the neck, which has cervical vertebrae and the muscles associated with them. In order to do that, first you have to sort of separate out in the layers between the two parts of the neck. Then you have to sever some of the ligaments that connect the dens of the axis, which sort of pokes up into the foramen magnum and attaches to the inside of the cranium. So you have to go in and sever those ligamentous connections. Then you sort of have to separate out basically the occipital condyles in the base of the skull from the atlas, which is also tied up in there. This can involve both scalpels and chisels. So there's also various, obviously, muscles that are attached to the back of the head coming up from the neck and the shoulder girdle, and you want to get rid of all of those. And then you're basically going to flip the head forward. So hanging on to the rest of the trunk, you'll see the front of the cervical vertebrae. And then looking down onto the back of the pharynx, you'll see all these nerves that we've talked about, 9, 10, 11 coming out of the jugular foramen, and a variety of other structures. Your sympathetics will probably be about half and half. Sometimes they stay with the root of the neck, and sometimes they push forward onto the pharynx. That's the bulk of the dissection. It's not that hard, even if it's a little gruesome. However, once you've got the pharynx pitched forward, you can look and try to find some of those structures that we've talked about on the back. You'll obviously find the sympathetics in both places. You should be able to find the glossopharyngeal. You should be able to find the accessory nerve coming out and going into sternocleidomastoid. And then you should identify the constrictors. The dissection actually says stop pretty slowly, but as long as you got the pharynx intact, you might as well just get as much of that stuff as you can. Tomorrow, just to continue in this vein, we're going to saw the head in half and cut the pharynx in half, which enables you to see the structures on the inside of the skull. You can see the inside of the nasal region. You can see the inside of the oral cavity in the mouth, the inside of the pharynx. So there's a lot of cutting and sawing and wrenching and pulling today. But get some help, because what people tend to do when they're trying to disarticulate the head is they take a knife and a chisel and they put it somewhere between about C4 and C5, and then they pull the head forward with half a dozen cervical